In this screencast, we're going to work on a function design that will use the list of integers type that we designed in the previous screencast. The problem here is design a function that calculates the sum of all the integers in a list. I'm designing a function, so as always, I'll work through the how to design functions recipe. I'll start with my type check annotation, and then I'll write the stub, including the signature and purpose. I'll call this function calcsum because there's a built-in function called sum, and I want to give this function a different name. I know my input is going to be a list of integers. The output type will also be an integer because it will be the sum of integers. For the purpose, I'll write return the sum of all integers in LOI. I also need to complete the body of the stub. Next is the examples. The first example that I want to include is the empty list. I want to be sure that this function will return 0 if I pass it the empty list. So the input is the empty list and the value that I expect is 0. I'll do an example with some positive numbers, so that should sum to 60. And I'll do an example with some negative numbers as well, which should sum to 0. Now that I've written the examples, I want to run the code to ensure that there's no syntax errors. 2 of the 3 tests passed, which might be surprising, but if we look at the stub is returning 0, and 2 of our tests are actually expecting 0. We don't have any syntax errors, which is what we care about at this point, but whether the tests are passing or not is meaningless because we haven't implemented the function body yet. The next step is the template. To determine which template I need to use, I need to look at the input type for this function, which is a list of integers. So I'll go to the data definition for list of int and copy the body of the template. I'll comment out the body of the stub and paste in the template and write a comment about where the template is from. The template is from the data definition for list of int. That's important because anyone who reads this function can go to the data definition design if they want more information. Now I need to think about finishing the implementation of this function. I know that I want it to return an integer, which is the sum, so I'm going to use my accumulator to accumulate the sum of the integers in the list as I go. Therefore, the type of my accumulator will be int, and the initial value will be 0. Before we've seen any integers, the sum is 0. As I go through the list, I have ... to remind me that I might need to do some work here. I might need to do a calculation or call a function, and what I have to work with is I, which is storing the current integer in the list, and the current value of the accumulator. Because I'm calculating the sum, I need to add them together. As we visit each integer in the list, we want the accumulator to hold its current value plus the integer that we're adding to it. Once we've iterated through the whole list, we want to return the value that's stored in the accumulator. Let's run this again to see if all of our tests are now passing. All of our tests are now passing, so that gives us confidence that we've designed this function correctly.